Welcome to Module 22, Programming Architecture and Reusable Logic. Good BAS software makes operating intent visible, isolates failure, supports testing, and remains understandable after the original programmer leaves. In this module, we organize logic into layers, define interfaces, use reusable modules responsibly, and expose reason codes so operators and future programmers can understand what the system is doing. The objectives are to organize control programs into maintainable layers, separate physical I/O from equipment logic and supervisory strategy, reuse logic without hiding project-specific requirements, define interfaces and data contracts, expose state and reason codes, and review software for clarity, testability, and safe failure. The core concept is that good control software is explicit, layered, testable, and recoverable. The goal is not one clever program filled with hidden references. The goal is clear responsibilities, defined inputs and outputs, visible command authority, and software that another qualified person can troubleshoot and maintain. A maintainable BAS program can be organized into layers. Physical I/O handles raw input, scaling, validation, filtering, command, and feedback. Equipment logic owns local states, safeties, permissives, loops, and failure response. Supervisory strategy coordinates reset, staging, scheduling, optimization, and demand response. Operations and integration expose alarms, trends, graphics, diagnostics, analytics, and data exchange. Physical I/O and validation convert raw values into trusted signals. The layer should define input type, range, scaling, units, update age, quality filtering, and fallback. It should also define command scaling, feedback, proof, and failure response. Critical values should not be treated as valid simply because they display a number. An equipment module should own a clear function. A fan module can accept enable request, safety permit, local remote status, proof status, and speed request. It owns the state machine, timers, permissives, limits, and failure response. It publishes command, proven state, availability, active interlock, alarms, runtime, and reason code. Supervisory strategy should coordinate local logic, not replace it. It may own reset, staging, schedules, optimization, demand response, and coordination. Local equipment logic owns safeties, permissives, proof, basic loops, state transitions, and safe shutdown. Loss of an enterprise service should degrade optimization before degrading safe operation. Reusable logic can improve consistency for common functions such as sensor validation, command proof logic, runtime accumulation, lead lag selection, alarm persistence, and bounded reset. A reusable block should document inputs, outputs, parameters, modes, limits, and failure behavior. Version changes require regression testing because one library update can affect many equipment instances. Interfaces and data contracts prevent hidden dependencies. A terminal may publish a pressure request and the air handler consumes the request. The air handler should not read undocumented internal values from every terminal. A data contract defines meaning, ownership, units, valid range, quality, update behavior, default state, and fallback. State, reason, and quality turn invisible program decisions into evidence. A zero output is not enough. Operators need to know whether a fan is off because of schedule, smoke mode, failed proof, maintenance test, or no demand. Major equipment should expose state, commanded mode, availability, active interlock, active override, and reason. Each module should support controlled testing. Tests should include sensor failure, interlocks, mode transitions, overrides, output limits, and recovery. Version identifiers, release notes, and approved backups should accompany every release. Library updates need regression review because they can affect many equipment instances. Use this field checklist before releasing control software. Document program layers and ownership. Confirm reusable blocks have defined interfaces and versions. Inputs need units, range, quality, and fallback. Major equipment should expose state, availability, and reason. Timers should be tied to intent. Test normal, abnormal, and recovery states. Confirm backups and peer review. Let us summarize. Programming architecture separates physical I/O, equipment control, supervisory strategy, presentation, and integration. Reusable blocks need documented interfaces, parameters, failure behavior, and versions. Data contracts define meaning, units, range, quality, freshness, fallback, and ownership. State, reason, availability, and quality make software decisions visible. Testing, backups, and version control protect maintainability.